दृष्टुं ज्वलन्तं सर्वतोमुखं नृसिंहं भीषणं भद्रं मृत्युं नमाम्यहम्. So balancing equations by ion electron method of redox reactions. So we have discussed some reactions involving potassium permanganate and potassium dichromate. So we have taken, again I am repeating the rules which we are adapting. Ascertain the oxidized state and reduced state of the substances, then write the equations for oxidation for reduction separately, then find out their equations in ionic form for half reaction of oxidizing agent, half reaction of reducing agent. Then we adapt rules for balancing both equations. So balance the atoms other than oxygen and hydrogen by multiplying with simple whole numbers. Then second, balance the oxygen atoms by adding water molecules on the other side. By balance the hydrogen atoms by adding hydrogen ions on the other side. Balance the charges by adding electrons. Then we got the equation for half reaction, and we got the equation for half reaction for oxidizing agent and reducing agent. So now, since substances when react by their equivalences, so the number of electrons involved in for oxidizing agent will be equal to the equations electrons involved for the reducing agent. So to cancel out the electrons, we multiply with the simple whole numbers, and then we add the equations to get in the balanced form equation, and this method is called balancing redox reactions by ion electron method. Now let's come to the two things I have told you. For standard equation for potassium permanganate, we have derived MnO in acidic medium, MnO4 minus 8H plus 5E Mn plus 4 water. For potassium dichromate, we got in acidic medium Cr2O7 minus 2 plus 14H plus 6E forms 2Cr plus 3 plus 7 water. So here it indicates in the potassium dichromate we got 14H plus in the left side. It indicates the potassium dichromate is a very good oxidizing agent in acidic medium, and generally the acid is used here, dilute sulfuric acid, and the 6 electrons involved there, it tells us that the equivalent mass of potassium dichromate is molecular mass by 5. In the similarly, in case of potassium permanganate, we get MnO4 minus for 8H plus 5E is Mn plus 2 for 4 water. So there we get 14 this 8H plus. It explains that the potassium permanganate is a very good oxidizing agent in acidic medium, and there the 5 electrons explains us the equivalent mass of potassium permanganate is molecular mass by 5. Now let's take the equation for potassium dichromate, dilute sulfuric acid and H2S. So we'll take potassium dichromate and dilute sulfuric acid plus H2S. So I'm not writing the ionic form, I am writing the, so this method I am teaching you students the only because in book what happens, he has given the left side, he has given the right side, he has asked you to balance the equation. I am not doing that. I am trying to get both left side and right side. So I am giving you the reagents. Potassium dichromate in dilute sulfuric acid reacts with H2S, find out the product and balance them in ionic form. So we got the potassium dichromate equation, we got K2Cr2O7 plus 4 sulfuric acid. For sulfuric acid we get the K2SO4 Cr2SO4 thrice plus water plus 3O. Then that O comes oxidizes hydrogen sulfide to sulfur. So here the potassium dichromate K2Cr2O7 is in acid medium becomes Cr2SO4 thrice, and H2S will become sulfur. Why? Now this H2S, the O of potassium dichromate react with H2S plus O to form H2O plus sulfur. So oxygen oxidized sulfur. So these are the equations, half reactions for this. So we'll write this in ionic form, we will write this in ionic form. So for this potassium dichromate, what is that? Cr2O7 minus 2 is forming 2Cr plus 3. 2Cr plus 3. So somebody may question, sir, why not potassium you are taking? Now because the oxidation number of potassium is not changing. K2Cr2O7, or next side comes K2SO4. And this side sulfate, that side sulfate. So there is no change oxidation number for potassium, no change in oxidation number for sulfur. That is the reason we are not involving them. We write the ionic form of those reagents whose oxidation number is undergoing change. So when oxidation number is increasing, it is oxidation. When oxidation number is decreasing, it is reduction. So Cr2O7 minus 2Cr plus 3, half reaction, and then here S minus 2 is forming sulfur for this reaction. Sulphide is become oxidizing to sulfur. So this is one equation we got. We will get it in ionic form, and we will get it ionic form and balance them. So for this, what to happen? Cr2O7 minus 2 is forming 2Cr plus 3. So we have 7 oxygen. So balance the oxygen atoms by adding water molecules. They balance the hydrogen atoms by adding hydrogen ions, 14H plus, because we have 14 hydrogen atoms, we have 14H plus. Balance the charges by adding electrons. We will add 6E. Why? Now because here we have 14H plus minus 2, it becomes 12H plus, and this kind 6H plus, 6 positive, this side 12 positive, so we add 6E. So this is the standard equation for potassium dichromate. Then what happens for sulfur dioxide? Sulfur dioxide S minus 2 is forming sulfur. So no change in atoms, so minus 2. So balance the charges by adding electrons. We got 2 electrons. We have got so half reaction of oxidizing agent and half reaction for reducing agent we got. Now we will balance. So this equation we got Cr2O7 minus 2 plus 14H plus 6E forms 2Cr plus 3 plus 7 water. This is the half equation of oxidizing agent, and S minus 2 is forming sulfur. This is the half reaction plus 2 electrons, half reaction for reducing agent. So 6 electrons here, 2 electrons. So we have to multiply this equation by 3 and add. So we'll get Cr2O7 minus 2 plus 14H plus S minus 2, 3S minus 2. 3S minus 2 will give us 2Cr plus 3 plus 3S plus 7 water. So the potassium dichromate is reduced to oxidizes, reduced to Cr plus 3, and S minus 2 is oxidized to sulfur. So sulphide is oxidized to sulfur, and potassium dichromate is oxidized to Cr plus 3. So this reaction is the color of potassium dichromate ion is orange yellow, and the Cr plus 3 ion is green. So if you take potassium dichromate, add sulfuric acid, pass H2S gas through that, you will get a green solution, and sulfur particles will be floating. The sulfur particles are yellow. They are yellow particles, and there are colloidal particles. They will be floating on the solution of chromic sulphate. So it's a very interesting reaction. You have in your syllabus, second year, you have your oxygen family, and there you will have sulfur dioxide, sulfuric acid, and H2S. Three topics you have in your oxygen family. So almost all these reactions which I am solving here, balancing them by partial equation method and ion electron method, I am completing your second year syllabus to some extent. When you will read second year, these reactions are equipped, and there when you will write the preparation property very easily, you can write the preparation property of the compounds. So try to learn them. So to one, twice, thrice, 4 times. Don't get tired, don't get disgusted, don't feel that I cannot do it. If you try, you will definitely do it. Always don't depend much upon the book, my children. Many often we copy from the book. Many often the book the way right, I am right. You read the book, try to understand it, apply your thinking, and have your own imagination and have your own representation. If you have your own representation, then automatically you are unique. One can be best, but the person who is unique is much better than the best person, because many best persons will be available, but unique, when you are unique, it's your own way of doing things. You try to have your own way of doing it. If you once you do it, you are different from all others, and you will be definitely accepted by people in a unique manner. So always I am appealing you, try to understand, read to learn to understand, and once you understand, you have your knowledge, and the knowledge is a synthesis, the knowledge is a synthesis, and by synthesis you got it. So this remains, the seed of the wisdom remains with you. Any question, any related question is coming on that, you will be in a position to answer them very beautifully, and your answers will be accepted by everybody, because your presentation will be definitely different from all others and will not be like a book, and it will be your own presentation. Now let's come to another equation. Let's take potassium dichromate, K2Cr2O7 plus sulfuric acid plus potassium iodide. We'll go to this reaction. So iodide, so now Cr2O7 minus 2, potassium dichromate K2Cr2O7 is becoming what? Cr2SO4 thrice. So we have done so many reactions. So we got this equation for potassium dichromate, and Ki, the O of potassium dichromate, will oxidize iodine. Will oxidize iodide to iodine. So these are the ascertain the oxidized state and reduced state of the substances. Potassium dichromate will be an oxidizing agent, and potassium iodide is a reducing agent. So the potassium iodide will become iodine, and potassium dichromate will become chromic sulphate. So now we'll put this in ionic form and put this in ionic form. So like potassium dichromate, we will write at Cr2O7 minus 2 will form as Cr plus 3. So 2 chromium, so 2 Cr plus 3. So this is the equation for potassium dichromate, and ionic form I minus is becoming I2. I minus will be becoming I2. So 2I minus will become I2. So we'll balance this equation in ion electron method. We'll balance this equation ion electron method. Then we will try to cancel out the electrons. So Cr2O7 minus 2 we have, this is becoming 2Cr plus 3. So 7 oxygen will add 7 water, balance the oxygen atoms adding water molecules. So we increase the hydrogen atoms, balance the hydrogen atoms by adding hydrogen ions. So we have 14 charges, this had 12 charges, this had 6 charges, balance the charges by adding electrons. So this is the ionic form of potassium dichromate, Cr2O7 minus 2 plus 14H plus 6E, 2Cr plus 3 plus 7 water. Then comes I minus, 2I minus is becoming I2. So we'll have 2 electrons. 2 electrons now. So here 2 electrons, here 6 electrons. So this is the, we will multiply by 3 and add. So Cr2O7 minus 2 plus 14H plus 6I minus, and you will form 2Cr plus 3 plus 7 water plus 3I2. So iodide is oxidized to iodine and potassium dichromate is reduced to Cr plus 3. So this reaction you will be doing in practical. In the practical, when you are doing iodometry titration, here we will take a solution of potassium iodide and the iodine will be liberated. We will that estimate that iodine liberated, because substances when react by their equivalent amounts. So this is a very question, iodometry one titration we will be doing in our second year. So there you will, this equation we will be involving. So this is the equation for potassium iodide with potassium dichromate. Let's take another reaction of potassium dichromate with hydrochloric acid. Potassium dichromate, so we'll take a HCl. Same thing. So here ionic form of potassium dichromate is Cr2O7 minus 2 plus 14H plus 6E will give us 2Cr plus 3 plus 7 water. And we have Cl minus is forming Cl2, because this is the equation. We have the HCl, the oxygen liberated by the oxygen comes from potassium dichromate, oxidizes HCl to form water and chlorine. The oxygen coming out from potassium dichromate will oxidize HCl to chlorine. So Cl minus is forming Cl2. 2 chlorine atoms here, so we multiply this by 2. 2 negative charges, so we'll add 2 electrons. And since 6 electrons, 2 electrons, we multiply this by 3 and balance. So Cr2O7 minus 2 plus 14 H plus 6 Cl minus will give us 2 Cr plus 3 plus 7 water plus 6 Cl2. 3 Cl2. So here potassium dichromate is oxidizing HCl to chlorine. Hence, that is the reason always we are acidifying potassium dichromate by dilute sulfuric acid. We never acidify potassium dichromate by dilute by concentrated hydrochloric acid or by hydrochloric acid, because potassium dichromate, while carrying out the reaction, will also consumed by the HCl. Hence, all acidification, whenever potassium dichromate oxidation reaction is carried out in acidic medium, the medium is always used as dilute sulfuric acid. So these are the few reactions involving potassium dichromate. Now we'll come to a reaction, sodium sulphite reacting with iodine. So now let's come to this. Another equation I am taking, Na2S2O3 forms iodine. We will balance this for ionic form, write the ionic equation. So here iodine is the oxidizing agent, and sodium sulphite is the sodium thiosulphate is reducing agent. This is called sodium thiosulphate. Sodium thiosulphate is called, and its name is hypo. Also it has a name HYPO, hypo. They call it hypo, means sodium thiosulphate. The other name for sodium thiosulphate is hypo. So this is a very important reaction. We will be using our iodometry titration reactions. So sodium thiosulfate will be oxidized by iodine to sodium tetrathionate. So this will form. So if you write the equation, Na2S2O3 plus iodine, this will form Na2S4O6 plus sodium iodide. So this is the equation for this. I am not balancing this, I will be balancing by ionic form. So what is happening? Sodium thiosulfate, what is the oxidation number of sulfur here? Sodium is +2, oxygen is minus, so 2x. So if you calculate it is x, so here is +2 plus 2x minus 6 is equal to 0. So 2x is +4, so x is +2. In sodium thiosulfate, it is +2. So +4, you have minus 6. So +2 +4, we get minus oxygen is -6. So +2, there +4, 2. So +2 oxidation state. In sodium thiosulfate, it is the oxidation number of the sulfur. We are calculating x. So +2 plus 4x minus 12 is equal to 0. So 4x is equal to 10. So x is 10 by 4 plus 10 by 4, that is 5 by 2. We have the oxidation number. So it is sodium thiosulfate is oxidized by iodine to sodium tetrathionate. This 5 by 2 comes to plus 2.5. So oxidation number is increasing, and iodine is 0 and it becomes I minus. So this reaction is iodine to iodide is a reduction reaction. And sodium thiosulfate to sodium tetrathionate is an oxidation reaction. So this is the chemistry behind this reaction. Now we will go to the balancing part of the equation. So then what happens? Thiosulfate is forming tetrathionate and iodine. So what the rule says? Write down the oxidized and reduced state of the substances in ionic form. So thiosulfate NaS2O3 minus 2 is forming S4O6 minus 2. Sodium thiosulfate is becoming sodium tetrathionate, and it is iodine is becoming I minus. We will balance this and we will balance this. So find out the oxidized and reduced state of the substances in ionic form. We got in the ionic form. Then let's first balance S2O3 minus 2 is forming S4O6 minus 2. What the rule says? Balance the atoms other than oxygen and hydrogen. Balance the atoms other than oxygen and hydrogen. We have sulfur atoms here, 2 sulfur atoms, 4 atoms. So we multiply by 2. We have 4 sulfur atoms. We have 2 sulfur atoms. So we multiply this by 2. Then we have 3 into 2, 6 oxygen, and here is 6 oxygen. So oxygen are balanced. Then we will come to balance the charges. We have minus 4 charge. Left side you have got minus 2 into 2. Minus 4 charge. This side minus 2 charge. So we will add 2 electrons. Then I2, iodine, is becoming what? I minus. So balance the atoms. So we have 2 iodine atoms. We multiply this by 2. We have 2 negative charges. We'll add 2 electrons this side. So 2 electrons there, 2 electrons here. So there is no use of, electrons will cancel as such. We'll have 2 S2O3 minus 2 plus iodine. It will form S4O6 minus 2 plus 2I minus. This is the balanced form of the equation. So thiosulfate is becoming tetrathionate, iodine is become 2I. Now you see here, two thiosulfate molecules are involved with 2 electrons. So generally students do a mistake here. So equivalent mass of sodium thiosulfate will be what? Molecular mass by 2 they will make it. Why 2 electrons? No, not 2. It will be 2 equivalents have 2 electrons. So one equivalent will have 1 electron. So sodium thiosulfate equivalent mass will be equal to molecular mass. And iodine, thiodide, 1 electron is involving. So this is the way. So whenever you are balancing the equation, children, try to learn what this equation tells me, the chemistry of the equation. So whenever you are say I am balancing equations, then your concentration only balancing, you will not learn anything. But the moment you balance the equation and think what I am going to learn from this equation, so that will give you a lot of things. This you will be reading in your second year while doing the sulfur family. So there you have sodium thiosulfate, chemistry of sodium thiosulfate. This equation will be very much used for this. Now let's come to the equations involving concentrated sulfuric acid. Now this concentrated sulfuric acid is a oxidizing agent. We have done many reactions involving this concentrated sulfuric acid. So concentrated sulfuric acid is an oxidizing agent because in sulfuric acid the sulfur is in +6 oxidation state. So this decomposes in presence of a reducing agent. This recomposes to form H2O plus SO2 plus O. So it is producing one nascent oxygen. Hence it is a oxidizing agent and liberates sulfur dioxide. So this oxygen carries out the oxidation reaction and makes it to be an oxidizing agent. So we'll now write the chemistry of balancing copper plus concentrated sulfuric acid. This equation very much we are using in preparation of sulfur dioxide. A chapter will read preparation properties of sulfur dioxide. There you will be having this preparation of sulfuric acid. Sulfur dioxide is done by heating concentrated sulfuric acid with copper. So we'll write the ionic form there. So what's happening here? Let me write first the equation. So this O will react with copper to form copper oxide. The copper oxide is a metallic oxide and metallic oxides are basic. So this copper oxide will react with sulfuric acid. So this copper oxide will react with sulfuric acid to form copper sulfate plus water. So this is the reaction of copper with concentrated sulfuric acid. Copper oxide cancels and OO cancels. So we get the equation copper plus 2 sulfuric acid to forms copper sulfate plus sulfur dioxide plus 2 water. So this is the sulfur dioxide comes out. Hence this is a useful method for preparing sulfur dioxide. We take in a round bottom flask the concentrated sulfuric acid, add copper toning through this copper toning, and we have a delivery tube. By heating, the sulfur dioxide gas will come out. We will prepare sulfur dioxide. Now we will balance this equation in ionic form. This is a partial equation method balanced. We have done this. Still I have done it again so that you will learn the chemistry from here. So what is happening? Copper is becoming copper sulfate. Copper is becoming what? Copper sulfate. And sulfuric acid is becoming what? Sulfur dioxide. So they are the forms. So write the oxidized reactions for oxidizing agent and reducing agent. So we'll now write sulfuric acid equation. We will write forms what? Sulfur dioxide. We will balance this. And copper is forming copper sulfate. We will balance this. So its oxidation number is not changing. So we will not balance this. Only we will balance the copper. So first we will sulfur dioxide. What ionic form of sulfuric acid? SO4 minus 2. And sulfur dioxide, it is forming sulfur dioxide. So how many oxygen atoms are here? We have here 4 oxygen atoms and here are 2 oxygen atoms. So add 2 water molecules to balance the oxygen atoms. So how many hydrogen atoms we got? 4 hydrogen atoms. So balance the hydrogen atoms by adding hydrogen ions. Hydrogen ions. Then balance the charges by adding electrons. So how many charges this side? We have 4 positive, 2 negative. So we have 2 positive this side, no charge this side. So we will have to add 2 electrons. So SO4 minus 2 plus 4H plus 2 electrons will give us SO2 plus 2 water. So this is the standard equation for sulfuric acid as an oxidizing agent. So as an oxidizing agent, we got equation for sulfuric acid SO4 minus 2 plus 4H plus 2 electrons gives us sulfur dioxide plus 2 water. This is, we got the balanced equation. Now we'll come to copper. Copper is becoming what? Copper plus 2. Copper is becoming what? Copper plus 2. Copper is becoming copper plus 2. So we have atoms are identical, same. Only charge, we have 2 positive, 0. So add 2 electrons. So here are 2 electrons, here are 2 electrons. So they will cancel out. Just you add, you get copper plus 4H plus sulfate minus 2 will have sulfur dioxide plus Cu plus 2 plus 2 water. Balanced. This is the Ionic form of balancing. So sulfur dioxide with concentrated sulfur, copper with concentrated sulfuric acid. This is the equation for preparation of sulfur dioxide. So let's take another equation. Sulfur dioxide with concentrated sulfuric acid. With phosphorus. With phosphorus. How it reacts? Phosphorus. So phosphorus will become. So if you go to the what's happening? Sulfuric acid decomposes to produce H2O plus SO2 plus O. Okay. Now this phosphorus reacts with O to form P2O5, phosphorus pentoxide. Phosphorus reacts with oxygen to form phosphorus pentoxide. How many phosphorus this side? 2 phosphorus, 2P. How many O? 5O, 5O. Phosphorus balanced. So then P2O5 will react with water present here. Water to form phosphoric acid, H3PO4. Now we'll balance, add. So how many O? 5O. How many O here? 1O. So we will balance this equation. So how many phosphorus this side? 2 phosphorus. So we multiply this by 2. How many hydrogen? 6 hydrogen. We will multiply by 3. It is balanced. This balanced. Now that means what? You want 1 P2O5 and that can, so we have to multiply this equation by 5. So O will cancel, P2O5 will cancel, we will get 2 phosphorus plus 5 sulfuric acid then 3 water, 5 water. We will have 3 water here and other side we have 5 water here. So 2 water plus 5 sulfur dioxide plus H3PO4. 2H3PO4. So phosphorus is becoming phosphoric acid and sulfuric acid is becoming sulfur dioxide. So ascertain the oxidized state and reduced state of the substance. This is the way you are determining ascertaining the oxidized state and reduced state of the substances. If you, in a book, what happens? He gives the equation and asks you to write balance equation. That way you will not learn the chemistry. You will not be learning the chemistry. Here you are learning the chemistry. What happens? You have nitrogen family in second year. You have preparation and properties of phosphoric acid, phosphorus pentoxide we have. Now if we are learning now how to balance equation, then there you will not be feeling dejected. Many often in colleges, when the teacher teaches there, they give the notes just in a piece of paper. They write the note and give to the students, you read. And equation, now you will remember the equation. Children, take a oath in the name of Lord Lingaraj that I will not remember anything unless otherwise it is very necessary. Because if I remember, I have to forget. So let me now come to ionic form. Balanced ionic form. What is happening? Sulfuric acid is sulfate minus 2 is forming sulfur dioxide. This equation I will balance. And what is phosphorus? Phosphorus is becoming phosphate, PO4 minus 3, phosphoric acid. So these are the equations I got. Now I will write the equation for this. Sulfate minus 2 is forming sulfur dioxide. So how many oxygen here? 4 oxygen. So we'll add 2 water molecule on the other side. So we have 4 hydrogen. I will add 4H plus this side. And to balance the charges, I will add 2 electrons. So this equation tells me what? A sulfuric acid molecule involves 2 electrons. So the equivalent mass of sulfuric acid is molecular mass by 2. In reactions, when stoichiometric reactions, when numericals will come for sulfuric acid, you will be having the equivalent mass of sulfuric acid will be molecular mass by 2. Then phosphorus is forming phosphate, PO4 minus 3. So how many oxygen here? 4 oxygen. So we'll add 4 water molecules this side. 4 water molecules. So how many hydrogen atoms? 8 hydrogen atoms. So we'll add 8H plus this side. How many charges? 5 positive charge. So we'll add 5 electrons this side. PO4 minus 3 and 8H plus. So extra 5. So 5 electrons there, 2 electrons are here. So we will now multiply this equation by 5 and this equation by 2 and add. So we'll add here 2 phosphorus plus 5 sulfate, SO4 minus 2. Okay, then comes 4 water left side. We'll have 4 water left side and 2 water right side. So we'll multiply 2 phosphorus. So 8 water here. 2 into 4, 8. This side 10. So we'll have 2 water this side. 2 water and 2 phosphate, PO4 minus 3 and 5 sulfur dioxide. This is your balanced form. So 2 phosphorus, 2 phosphate. So this is the oxidation, and the sulfate to sulfur dioxide is the reduction, where the oxidation number of phosphorus is 0 and it is becoming phosphate plus 5. So you have here, this is the way the balance equation. So in all this, again I am recapitulating what I have done. While balancing any reaction by ion electron method, ascertain the oxidized and reduced state of the substances, then write the equation for the oxidizing agent separately and reducing agent separately, then represent them in the ionic form, then balance the atoms of oxidizing agent half reaction, reducing agent half reaction, then in each reaction balance the oxygen atoms by adding water molecules on the other side, balance the hydrogen atoms by adding hydrogen ions on the other side, then balance the charges by adding electrons. So you get two equations, one for oxidizing agent, the other for reducing agent. Since the substances when react, they react by their equivalences, so number of electrons of oxidizing agent will be equal to number of electrons for reducing agent. So to cancel out the electrons, multiply with the simple whole numbers and cancel out. So that is the rules we have applied for balancing equations, redox reactions for ion electron method. And in next class I will do some concerned nitric acid reactions, and we will do one or two reactions involving alkaline medium. If a question is given to us in alkaline medium, then how to balance the equation. This is the method for balancing both equations for the acidic medium and neutral medium. We go by this process. Alkaline medium means we will involve OH minus ion. Here you are adding H plus ion. Acidic medium, you are adding one H plus ion to balance. There you will have alkaline medium, you will add OH minus. That is the only difference. That is the only difference. Here you are adding H plus, there you are adding OH minus. So next class we will study the balancing equations, redox reactions by ion electron method in alkaline medium, and we will do some more reactions involving the concerned nitric acid, and that will complete our topic, balancing equations by ion electron method. Thank you students for your patient sharing.